Okay, so because we see statistics everywhere, we should have an idea of how to evaluate a statistical study. I mean, you can't watch TV or see any kind of ad without some sort of stats blaring in your face. So there are, I think, seven, two, three, four, eight guidelines, for evaluating a statistical study. So let's take a look at each of them. So first of all, you want to get a big picture view of the study. What was the goal? Like what were they trying to do with it? Who were they studying? What was the population? Population meaning just the people that they were looking at. Was the population clearly and appropriately defined? What type of study was it used? Was it observational? Was it experimental? Was it appropriate for what you wanted to study? Okay, you need to consider the source. Statistical studies are supposed to be subjective, but people who carry them out and fund them may be biased. For example, if you have a study based on the benefits of chocolate and it was funded by a chocolate company, there might be some bias there. There might not, but there very well might be. Okay, so look for bias in the sample. So there's a couple different types of bias. There's selection bias, and that's when researchers select the sample in a way that tends to make it up and representative of the population. So for example, if you're trying to take a poll of people who in their favorite grocery store, and you only interview those who are coming out of a specific grocery store, you're probably going to get bias towards that store because obviously they're shopping there. That means they like it, but it doesn't mean that it's going to represent the entire population. Okay, then there's what's called participation bias, and that is mostly with surveys and polls, because it's when the people choose whether to participate. And most of the time, the only ones who participate are the ones who feel strongly about an issue. So you're going to, you're going to get votes for whatever options you have available, but it doesn't mean it represents everybody. It just means those are the people who feel strongly about it. Okay, so the reason we keep doing it is because oftentimes, even an election, those who don't feel strongly about an election might not even vote. So doing a poll, for an election, might actually give you somewhat accurate results, because those are the people who are more likely to actually vote. Okay, next guideline is to look for problems in defining or measuring the variables of interest. So what is a variable of interest? So a variable is just something that can vary or take on different values. Just like in algebra, it's your x, y, z. All your letters, those are variables. But in life, it's just anything that can vary. Okay, a variable of interest then is the items or quantities that the study seeks to measure. Okay, it's what are you looking at? So for example, a commonly quoted statistic is that law enforcement authorities succeed in stopping only about 10 to 20% of the illegal drugs entering the United States. Should you believe this? Well, let's look at the variables of interest here. So there's two variables. They're looking at the drugs that are stopped. So they want the quantity of illegal drugs intercepted and the quantity of illegal drugs not intercepted, because that's how you can compare the percentage of one to the other. Okay, so we've identified them. So defining is fine, but let's see if we can measure them. So you can measure the quantity of drugs that are intercepted, right? That's pretty easy. However, how do you measure the quantity of drugs not intercepted? You would have to rely on people's testimony and admitting that they brought drugs over, but they didn't actually get intercepted. But that's pretty unlikely that anyone's actually going to report that amount. If you don't know the number of drugs that are not intercepted, you can't actually get that 10 to 20% statistic. This is, so in a New York Times analysis, a police officer is quoted as saying that his colleagues refer to this type of statistic as PFA, or pulled from the air. It's just a made-up statistic that they may have guesstimated based on just their viewpoints, but it's not based on anything concrete. Okay, the next one also has to do with variables. So beware of confounding variables. So the word confounding basically means like confusing. So these are variables that are not intended to be part of the study, but are going to be there anyway. For example, if you're studying the effect of something, let's say you're studying the effect of a certain workout regime. Okay, one group does the workout, another group doesn't. But one of the confounding variables may be like their diet, or it could be their job, whether they smoke or not. So there's other variables that are going to be there sometimes that could confuse your results. So you might not get completely accurate results if you don't take those variables into consideration. Okay, the next one, considering the setting and wording in surveys. Okay, so surveys. Even when a survey is conducted with proper sampling and with clearly defined terms and questions, it's important to watch out for problems in the setting or wording that might produce inaccurate or dishonest responses. So for example, the Republican National Committee commissioned a poll to find out whether Americans supported the proposed tax cuts. They asked, do you favor a tax cut? Well, if you're only asked that, then yeah, most people are going to say yes because they want to save money, right? So should we conclude that Americans supported the proposal? Well, the proposal has more, there's more in the proposal than just a tax cut. So no. So that is going to make a biased response because it doesn't give other options, it doesn't give enough information. So if the only thing is if there's no other repercussions, yeah, I favor a tax cut. But there's always going to be other things involved. So there were other polls conducted at the same time, showed a similarly large majority expressing great concern about federal deficits. So indeed, support for the tax cuts was far lower when the question was asked by independent organizations in the form, would you favor a tax cut even if it increased the federal deficit? So here it gave like the consequence of favoring tax cuts, so you can actually weigh in and give a more honest response. Okay, check the results are presented fairly. So study may be misinterpreted in graphs or concluding statements. Researchers may misinterpret the results or jump to conclusions not actually supported by the results. So for example, the school board in Boulder, Colorado created a hubbub when it announced that 28% of Boulder school children were reading below grade level, and hence concluded that methods of teaching reading needed to be changed. The announcement was based on a reading test on which 28% of Boulder school children scored below the national average for their grade. Do these data support the board's conclusion? Well, okay, so the actual statistic here was that 28% of Boulder school children scored below the national average for their grade. Okay, so 28% scored below, which means that 72% scored above, which is still pretty good. Therefore, the school board's ominous statement about students reading below grade level makes sense only if grade level means the national average. Okay, but those could mean completely different things, right? The interpretation of grade level, or this interpretation of grade level, is curious because it means that half the students in the nation are always below grade level, no matter how high the scores. So the national average could actually be, a grade above what their actual grade is, but if you take that to be grade level, that would, it doesn't quite mesh up. The national average could mean the grade level. But yeah, that does present a pretty bleak view on the nation, that if the national average is always grade level, then half the students, of course the average right there is in the middle, so half the students would always be below. And so that's probably not very accurate. Therefore, this conclusion, the teaching methods need to be changed, is not actually justified by this particular data. There may be other data that you can use to help support that argument, but in this case, it's not. Okay, the next guideline is stand back and consider the conclusions. Ask yourself the following questions. Did the study achieve its goals? Did it answer the question that it was asking? Does the conclusions make sense? Like, for example, this one, it didn't really make sense because we were making this wrong definition here. Can you rule out alternative explanations for the results? Okay, so could there be something else that happened that might have explained what we got? Okay, and lastly, if the conclusions do make sense, do they actually have any practical significance? So for example, we have an experiment conducted in which the weight losses of people who try a new fast diet supplement are compared to weight losses of a control group who try to lose weight in other ways. After 8 weeks, the results show that the treatment group lost an average of a ½ pound more than the control group. Assuming it has no dangerous side effects, does the study suggest the fast diet supplement is a good treatment for people wanting to lose weight? Okay, so it found that the treatment group lost an average of ½ pound more than control group. So, I mean, yeah, the fast diet supplement does help them lose more weight. So in a commercial, it may say that, and trying to market this fast diet supplement as, hey, all of our, in an experiment, we found that they lost more weight than people who didn't. Well, practically speaking, a ½ pound difference doesn't make much difference at all. So even if everything else was completely right, this experiment didn't really help decide anything. Like if this fast diet supplement was expensive, that ½ pound more would not convince me to use it rather than using something else. Okay, so that is 5B. It's just looking at experiments or looking at statistical studies and trying to decide whether it is something you can believe or not.